All right, I'm Steve Ickman. I'd like to welcome you to what's now, I guess, our third internal TypeScript Meetup. It's been a little bit longer this time than what I thought it was going to be, but it took us a while to get all of our schedules coordinated, and so now we're doing it, right? So I'm a dev in Fuse Labs, and Fuse Labs is part of Microsoft Research. We do a lot of social-related stuff, and we've been doing using TypeScript really early on, well before it was called TypeScript. We still are pretty heavy users of TypeScript. We, in addition to just building websites and web apps in TypeScript, we use it with PhoneGap and Cordova to build mobile apps. We use it with Node.js to build server-side code. So we're pretty passionate enthusiasts for TypeScript. And this meetup is just really a great forum for us to be able to meet with the team, get an update from them on where things are with the language, and just meet with other teams around the company that are also passionate about TypeScript. So the agenda is basically broken into two parts. So the first half, we'll kick it off with just passing the mic around, letting everyone kind of briefly introduce themselves. We'll get some opening comments from Anders, and then an update from Johnathan, and we'll do this really fun panel that we do where everyone gets to ask questions. If you're watching remotely, feel free to email me any questions you'd like to ask during the panel, and let's just kick it off with that.
Wanted to just sort of start off with a big thank you to all of the people who have been with us from the beginning or who have worked on TypeScript, and thank you to Steve for putting together these meetups. This is the third one now, I think, and it's been a little over a year since we had our last one, I think.
Yes, last June.
It's great. Without your help, we wouldn't be here, and it's particularly all these in-house teams have sweated the bullets in the beginning, in the early days of the language. And we're coming up on our second birthday, at least, officially, a second public birthday. Yeah, I guess the project is now probably, when did we start, Steve? Like four, almost 4 years? Yeah. So it
was October 2012 was the public CTP.
Yes. Yeah.
Next month.
That's right.
Round of applause.
Thank you. To the team. Yeah. We've come a long way, and in the couple of years we used to look in-house. We had a little bit of adoption. We're starting to see a good amount of adoption now. Certainly in-house, we've had that all along, but now also externally, we're seeing big corporations really sort of take a bet on TypeScript, and big open source projects take a bet on, like Shumway, for example, which is Mozilla's project to emulate Flash using HTML5. It's all built in TypeScript. Big consulting companies like Palantir and SitePen, JetBrains with all of their IDEs support TypeScript now, and there's Eclipse plugins. Facebook is using TypeScript to, I'm not sure if they're actually implementing in TypeScript, but they're certainly with their immutable.js, they're defining all of their documentation and type definition files in TypeScript. We're up to, I think, on definitely typed. How many of you are not familiar with definitely typed? So everyone, yeah. So definitely typed, I think, is now up to 600 JavaScript frameworks. It's quite amazing, and there's just an enormous amount of momentum out there. And we are literally becoming the way you write down metadata for programs written in JavaScript, which is great. And we're seeing people pick up on that trove of information indefinitely typed. Not even necessarily we're seeing people scrape that and then convert it into, I think there was some Clojure stuff, or there's like people using it for statement completion in their JavaScript IDEs, because heck, you can do so much better if you know all of this. So that's sort of been pretty cool. In terms of what's new, you may have all heard that we've switched to a new compiler code base. We did that in June. It's based on some experiments I started with back last year, and the results were pretty encouraging, and so we all decided to go with that, and we're productizing that, and basically I think we're like a week away from the first internal drop of it.
Yeah, it's going out in the spring, the Sprint 71 CTP of Dev 14, and there'll be an out-of-band release too. You can grab.
And this new compiler is it's about 4 to 5 times faster than the old compiler, and also uses a heck of a lot less memory. Between 2 and 4 times, well, actually more like 3 and 4 times less memory consumption. So we'll scale a lot better with this compiler. I know that some of you have been bumping your heads on the scaling ceiling, and then this thing should really help on that. And we are definitely very, very serious about getting to real scale, like a 1 million line code project. We should be able to open that in VS and not hiccup. We can't do that today, but we want to get there. It takes for us to do other things like library projects to get beyond that, and we'll do that too. But those are sort of some of the targets. I thought might be interesting to just talk a little bit about what's different about this compiler and why is it that much faster. One of the things so it was written to be as small and as simple as possible, and it was also written to sort of now that we're deep into JavaScript, I sort of set myself as a goal to try to write JavaScript code the JavaScript way, as opposed to write JavaScript code the C# way, which is different. There's a qualitative big difference between what you can do with function closures and so forth in JavaScript and the dynamic type system versus what you can do in the CLR in a C# or Java-like language. So in the new compiler, for example, you might be surprised that bullet number 3, we pretty much don't use classes at all. It's all functions and closures. So basically, everything's declared as functions, and then within those functions, there are other functions, and those are sort of your local methods. The entire type checker is one function. The entire parser is one function. The scanner is one function. And then we use plain old data interfaces to describe objects. So a lot of people sort of think that the core value proposition of TypeScript is classes, and that's definitely a big value proposition. But in my mind, the core value proposition has always been types and type checking and type inference and so forth, right? And this project has been interesting in that it really shows how types still, without using classes, add tremendous value. There's no way we could have built a new compiler without types. It would have been horrible. But it is an interesting coding pattern, this close. How many of you use that pattern extensively in your code bases? And how many write more like class style? Yeah, so there's a few people that use it, and it's not suitable for everything. It turns out to be quite suitable for things like compilers. And it's interesting in that your objects really, in a sense, become functions, and the data in your objects are your local variables, and you call a function that declares a bunch of local variables, and then you return out an object that has a bunch of function pointers in it, 2 local functions inside that function closure, and that's your object, if you will. And now you can invoke methods, and that sends you back into that function, and now you can operate on the local variables in there, and you have nesting of scopes and whatever. You have complete information hiding. And it works great for coarse-grained objects. It doesn't work so well for fine-grained objects because it's too expensive. You can't do it if you have millions of objects. And so you end up sort of practicing a style of encapsulation using functions for big objects, and then you use plain old data just for the little objects. And you don't have methods on them. They're just like objects with data in them. And then the methods are sort of on the bigger objects. Anyway, if you're curious, take a look at the source, and you'll see. we try to not do a lot of abstraction or whatever. One thing that tends to be true with JavaScript is that performance is directly related to the size of the code. The bigger the code, the slower it is to JIT it. And eventually JIT time ends up dominating. And with our old compiler, we were really we were getting hammered. And we were flooding Chakra's caches because there was just too much code. And so it would flush this cache and then it flushed the other or whatever, and it was just choking. And so with JavaScript, it's always important to think about code size. So that's an interesting learning. It's also interesting to not make sure in your code. I would say in your code, make sure that you make your code do the thing that the code is supposed to do, as opposed to I'm going to start by writing a 10,000 line abstraction library over data types, and then I'm going to write my app. Now you've already burned most of what of the available bandwidth by doing that, right? So in our compiler, we just use objects and arrays. That's it. Hash tables, it's an object. The properties of the objects are the entries in the hash table. Done. All the VMs optimize the shit out of that. So it's a great way to get yourself a hash table, right? And arrays are arrays, and that's it. Nothing else. Nothing more. And just keep it simple. It ends up paying off. Yeah. I can talk at length about what else goes on in there. One of the interesting things is we don't use null at all. It's all undefined. JavaScript is an odd language. It has 2 nulls. Who ordered that? I don't know, but it does. I mean, it's like reminds me of all of the days with Olay variants where there's null and nothing, and there's umpteen different ways of saying I don't know, right? Well, JavaScript is blessed with 2, and it's kind of crazy. You can't get rid of undefined because undefined is the default value of every variable, right? But you can get rid of null. There's absolutely no reason to use null in JavaScript. It doesn't serve any purpose that I can discern anywhere. It's just a singleton object that you can use, but you might as well use undefined. That's the default value. And people get so confused about which one it is, and I forgot to set my undefined to null. Well, what does it matter? So anyway.
In the Chakra engine, undefined is actually considerably faster than null.
Right. Because null is an object.
Yeah, but undefined is like a built-in concept.
Yeah. So. Okay. Another big piece of news is we moved to GitHub. Well, it's sad to have to clap at that. I mean, I would have. Trust me, we would have all loved for Codeplex to be the thing that we all wanted to move to and clap at, but that's unfortunately not the case. Particularly if you're trying to appeal to the JavaScript community, Codeplex is a very, very odd platform to do your appealing from. It just does not resonate with that community. Everyone is on GitHub in the JavaScript community, and we are now as well. And we are certainly seeing more engagement than we did on Codeplex. We have seen a few meaningful pull requests. We've actually taken some.
I was just kind of looking over there. If you look over at where it says unstarred 2000, so in our first couple of weeks on GitHub, we had already had more eyeballs on TypeScript than we ever had in nearly 2 years on Codeplex.
Yeah.
We pulled in more pull requests in the first few weeks than we had since we started taking pull requests, which was, I think, in March of this year. A lot of new faces, too. So instead of having the forums that we had on Codeplex, now people interact directly on bugs and feature requests. So you're working on an item, you're pushing forward on a goal together, and a lot of new people are jumping in with their ideas. And we've basically taken the design team and opened it up so that the features that people want and what we design are all in the open, and you can come and comment on that as they make progress.
Yeah, we literally have for the TypeScript compiler itself, That's it. It is all in the open. There's nothing. I mean, like the entire workflow, all issue tracking, all bug tracking, all code, everything is in GitHub. We still have parts in TFS, you know, because we also have a Visual Studio language service component, whatever that, and we only open source the TypeScript parts of that. But that's really just more. I mean, heck, we'd love for all of it to be there if we could. I personally, I use this workflow every day. It's a great workflow. It really works very, very nicely. Those guys they've sweat all the details in an impressive manner.
Yeah, to the point where you don't notice any complexity at this point.
Yeah.
The way we do pull requests and the way we work.
Oh no, we're delighting. I mean, we are literally turning bug. I mean, people will report a bug in the morning. It'll be fixed in the afternoon. They can pull a new version of the compiler. Done. I mean, it's just there's just no complexity, and we've made it so you can just drop that into your Visual Studio folder in the compiler directory, and you're done. You know, so keep it simple. Unfortunately, the rest of Visual Studio is not necessarily that simple. Anyhow, upcoming releases. So TypeScript 1.1 features the new compiler for batch compilation and for command line. It still uses the old language service, which we're actively gutting out right now. But that particular release will use the old language service. And then TypeScript 1.3, there'll be a 1.2, which is a stabilization if any is needed of 1.1. Then 1.3 then subs in also the new language service, which is new in 2 dimensions. Yeah.
What is a language service?
Language service is the thing that gives you IntelliSense and go to definition and refactoring and everything that binds that gives you semantic information and help inside Visual Studio, right? In TypeScript 1.3, the language service is new in 2 dimensions. It's new in that it uses the new compiler to provide all the semantic information. So when you press dot and get IntelliSense, that will be provided by the new compiler. And when you find all references, go to definition, whatever. And then it's new in that we will, on the managed code side, that is the part that binds us deeper into Visual Studio, we're using Roslyn's new language service, so the one that the C# and VB teams have worked on. And all of that premieres in November, according to plan. We will, that one, the Roslyn-based language, the Roslyn-based parts of the language service will only be available in Dev 14. So you would have to install Visual Studio Dev 14 CTPs in order to get that. We will also support Dev 12 for the batch compiler and for the JavaScript parts of the new language service, or the parts that are not written in managed code, if you get where I'm going.
If you want the fun bells and whistles of the tooling side is going to require that you grab Dev 14 and get Roslyn and all the new hot stuff on Dev 14.
But you won't have to switch.
You don't have to.
You can stick with existing.
There'll be out-of-band releases for Dev 12. If you want to stick on Dev 12, you can get all the way up to probably what will be 2.0 at that point.
In parallel with this, we are, of course, going to work on features.
Lots of features.
Lots and lots of features. So ECMAScript 6, which is sort of the next big event in the JavaScript community, was slated for ratification this December and has now been pushed out for an additional 6 months. So we'll likely see ratification of it next summer. It includes a whole slew of new features in ECMAScript, and of course our claim to fame is that we provide strong typing on top of JavaScript, and that means we need to also support all of these ECMAScript features. So in a sense, our laundry list there is clear. It's like we got to support all of ES6 ultimately. Now, the way we stage it though is we have a couple of guiding principles, I would say, when we weigh these proposed features. One is, of course, listen to feedback. We get a lot of feedback. We got a lot of feedback on Codeplex. We're getting a lot of feedback on GitHub and from internal users. And And there are features like abstract classes and whatever, that just to name one, that is, I think that's the number one requested feature, is it? Yeah.
Not in protected.
Yeah. So that's one way, one thing, of course. Then of course, yes, we got to get to completion on ECMAScript 6. But the way we get to completion is we sort of give a higher weight to features that we could provide with a down-level story, because a down-level story means that you could use that feature everywhere. Like certain ECMAScript 6 features, there is no meaningful down-level story. Take let and const, for example, or block scoping of local variables. The only way you could emulate the precise semantics of that is by turning every nested curly pair, or at least with new local variable, into a function closure and then immediately invoke that, and that would be horribly inefficient. And so we're not going to do that. So that feature is really only, there's no shortage of ugly ways to do it, but there are no good ways to do it. So that feature is really only valuable if your ultimate runtime target is ECMAScript 6. And there are not going to be a lot of ultimate runtime target ES6 for a while. However, other features like, say, destructuring, we can actually provide a very meaningful down-level story where we turn, just like we do for classes today, where you can get the feature, but use it now anywhere. And those are the ones that we value higher because they deliver a lot more bang for the buck for our users, and therefore, that's where we're going to go first. Here's a list of these are not in order though, are they? Or
they're from priority. Yeah.
What's that?
They're in priority order.
They are in priority order?
The ones that, so we did a small brainstorm the last couple weeks. We did a voting round with some internal users. And we kind of want to open this up to the broader internal TypeScript groups here that are using TypeScript to get their feedback on the proposed features. I would love to kind of talk offline, or we can do this as part of the Q&A, and you can kind of voice your own opinions about what's important for your team and why it's important for your team, just so we can kind of collect that and use that as we do the prioritization of this list.
Yeah. So, well, I don't know. Should we go through?
Yeah, I mean, we can go through some of it. Just topically, the kinds of things that Anders already talked about, like ES6 alignment. I mean, that's absolutely important. That covers quite a bit of the top section. Protected is just the protected keyword. Annotations are a way of annotating metadata. This actually came up in the previous TypeScript Meetup, and we talked quite a bit about how annotations might work. I think we're again coming back to it. We had feedback from the Angular 2.0 team. They're in contact with us and saying we would really like to ship with TypeScript support out of the box in Angular 2.0. But what we need from you guys is a way of being able to document how dependency injection is going to work. So we're looking at ways to do that in the TypeScript language or in the tooling so that they can do that and get nice support out of the box in Angular 2.0. The rest are ES6. There's abstract for abstract classes. DTS generation. This is kind of just kind of an Achilles heel for some people as they do more complex automatic generation of DTS files. They may trip over the fact that, if I do export equals and I'm using a type that is not exported, it just gives an error. It doesn't do anything really helpful for us. So ways of being a lot smarter about how that works. Then it's kind of everyone's laundry list. And I'm sure everyone here has their own 3 things they would like to add to the second page. But, override keywords and union types, conditional functions. So these are functions that could compile away, like a debug function that would compile away when you're in release mode, anonymous modules and so forth. And you can kind of see there's definitely a feeling of some of the C# developers coming in TypeScript and wanting to turn TypeScript into C#, and I totally can empathize with that.
Where's async await?
So async await.
No,
so
it's there, but the one problem with async await is that we don't believe that it is meaningful unless you have ES6 as a runtime target.
I see. Okay.
But Ron Buckton actually has been working on moving his async await prototype to the new compiler, and I think he's close, right?
He said he's got a few more weeks on it. So we will actually hopefully have a spiked prototype of what async await would look like, even with just ES3, ES5.
And basically with unrolling your methods and making state machines out of them, and like it's going to make spaghetti out of your code. But it's going to be interesting to see. I mean, maybe.
That's what source maps are for.
Yeah. Well. Yeah.
Nice.
Well.
And something that kind of is poking out a little bit in this list, but is really on our radar, is that a lot of people have problems with Cohen contravariants. Like they expect the type system work in a very particular way that's a little bit more strict than the default TypeScript does the checking. Now, of course, TypeScript tries to balance between type safety and the utility of the language. Like, it shouldn't be getting in your way. But for some people, as they build up their application, they want to just crank all the type checking to 11, get all the errors they can, and then fix those and have a high confidence in what they're shipping. So we're also thinking about what we're tentatively calling a stricter mode on TypeScript, where there's a set of additional checks that it will be doing that give you that extra level of confidence. Should I show off a little of this?
I think that's sort of it for slideware. Johnathan.
I figured out how to do this. VGA. Maybe. Hey. So what I've got here is just kind of just to whet the appetite for the upcoming versions of TypeScript on Dev 14. This is TypeScript, the new compiler. It's got the Roslyn integration. You can see the telltale sign of the navigation, the 3 navigation bars, which is the current Roslyn-enabled capabilities in the IDE. But most of it should look quite familiar. One of the things that integrating with Roslyn allows us to do is that if we start typing, for example, element, as I type element, it's not going to just look for, starting with element, it's going to look for wherever element is part of that word in some meaningful way. So we get that nice improved IntelliSense. As Roslyn support gets better, we'll be able to do color highlighting of the text here to give it kind of a more.
Our
yes.
IntelliSense works that way already. So you already do get that.
What was the additional thing?
I don't know. I haven't.
Okay.
I haven't seen it, so, but
I was under the impression it did not.
no, it does.
Okay.
It already searches within the words.
So what you want to try is capitalization
Capitalization.
Oh.
So do like camel case matching kind of thing. So
Yell it out. Go ahead.
lowercase a, capital E, probably.
Ah, okay.
Yeah.
Okay.
Okay.
So it does. Yeah. There you go. Ooh. Ah.
Oh, that's subtle.
Yeah.
I do that all the time.
Right. One of the other things that it does here is that you can see I've got a function and a function down at the bottom. Let me actually scroll it for people in the back. So we've got a function and a function. Before, I wasn't able to navigate directly to definitions inside of functions. So these functions and a function embedding feels much more natural in Dev 14.
What if there's a function within bar?
Within what?
Within bar.
Oh, I don't know. Maybe it'll give you another drop down.
Do it. Let's see it.
Okay.
Yeah, that's right. I love it.
Go inside, all right, and then drop
Okay.
down.
Okay.
Ooh, oh, nice. Okay. So it looks like there's some cute features, and as we begin to align more and more with Roslyn, more and more of the kind of the nice Roslyn experience will light up. But what this also does is it allows us to align across languages. So as we push forward on what language features are support or what tooling features are supported, we can much easier get in line with the new features that C# provides. That's the end of my little demo.
Okay.
Yes. So
There you go.
I'm curious if you could describe a little bit more about the open source workflow, I guess. Like, for example, how do you sort of filter out commits and then kind of squish them together before you push it out to the community? What do you do with, say, a pull request that you disagree with conceivably, or where it feels like they've forked off into a different version of TypeScript that's not part of the common train you want to support? Just a little bit more on how do you interact with that open source community?
well, we have this I mean, you guys can talk about
There's
it
a
more
mic
because
that
you
you
made
guys
it,
can use.
but at least from my vantage point, everything starts as an issue in the issue tracker. Typically, we haven't seen anyone just blast in with a pull request yet, but the issues, sort of show up, and we triage them pretty quickly and add appropriate tags. Are they bugs or are they suggestions? And do we need more info? We have tags for that we quickly put on them so we can.
Is that internal?
That's the team. Yeah. So the team is constantly sort of calling incoming new issues and putting them in the right bucket. If people haven't already done it, or reclassifying it. A lot of people will say it's a bug when it's really not a bug or more a suggestion or whatever, right? Then we just engage in discussion with people on there, and I think we're still learning to find the tone. We try to not be too dismissive, but on the other hand, it is okay to say no, we don't like this, or we don't see the value, or we tag it with need more info, and is there a particular scenario for which this is important? And often other community members will jump in and go, nah, we don't actually think this is, and then that can save you. Or you can point at, well, this is, ES6 doesn't have this, and we're trying to align with ES6, and so.
Actually, one of the nice things, and I kind of alluded to it earlier, is that the design team itself now works on GitHub.
Right.
So our own features that we're developing, our own specs that we're working on, we make them issues on GitHub. We write the spec in the issue tracker. People can comment on it. We can revise it. They can bring up, well, what about this corner case or whatnot? And we can do the same thing for the community. The community has all kinds of ideas for features that they want to see in TypeScript. They can, once they've seen how we do our specs, they do their specs like that. And then we can comment on that and iterate. So it's a different process than we've done before, but so far has actually been pretty effective.
One thing, the major highlight here is that we are doing everything in the open.
Stand up.
We're doing everything in the open.
Mohammed.
So we're doing everything in the open, and we're trying to move all our processes. We're trying to move all our discussions on the GitHub site. And as a result, just like what Hans mentioned and Johnathan, is that you get people giving you comments on bugs, and not just bugs. They get people looking at your code reviews and giving you comments on that, which is it's just a different dynamic. But yeah, once you do everything in the open, you start getting people inside. You still have maintained the ownership of the project, so you can decide what is okay, what is not, what is you're okay with people discussing, and what is an idea that is just like totally off topic and we're not going to pursue it.
Right.
But in general, you're just like including people into just like bigger team room with everybody involved.
And that transparency, I think, one of the things that we tried to learn early on from the TypeScript on CodePlex point of view is that people would suggest things or they would have particular bugs, and there would be kind of a disconnect because our CodePlex and our internal TFS were completely separate, and really we were working on the TFS. Yeah. Same thing on the design team. All the design notes were completely internal. They weren't external. And I think when people could actually see on GitHub us doing everything directly on there, they trusted us. There's a lot more visibility in how we work. So there's a lot, I'd say that fosters a lot of positive energy, and a lot of new people are coming on and jumping into the project.
And I think a higher quality bar too. Like I've been really impressed. One thing that happens is people don't get too far in proposing something before they see the quality of what everyone else has done. And so people can see, wow, this person put a lot of time and effort into being careful about thinking about the feature and writing it down carefully. And so actually, since we've been on GitHub, the quality of people's requests has gone up a lot, like in terms of the research that's gone into them.
In part due to some of the heroic efforts of some of the people that aren't here, sadly. So Ryan and some of the E&I guys are on there all the time trying to get people to write better bugs, better feature requests, and it's helped quite a bit. Next question.
Other questions? Other questions? Go here.
So when I started using TypeScript 2 years ago, TypeScript was sort of on my critical path of things not working quite right or features. It no longer is. It's really the ecosystem around it. How do you build a library in TypeScript? How do you minimize the size of the library in TypeScript? How do you build unit tests if you're doing TypeScript when you don't? There's the whole issue around a JavaScript engine. How is there someone on the TypeScript team whose job it is to track the ecosystem issues? and figure out how to make that larger environment work. Because right, the quality of the job you guys are doing, it's sort of, you've taken yourselves off the critical path of what needs to be improved at some point, where it would be great if there were more focus on figuring out those ancillary issues.
Yes, me. Email me. So yeah, our focus was trying to get the compiler, like you're saying, out of that critical path. Anders' work and a lot of the effort that the team has been doing on optimization has done quite a bit so that we can do larger scale, more iterative development. Definitely on the path is once we start getting to 100,000 million line projects, we've got to be able to break them up. We've got to be able to test them. We've got to be able to think of them more modularly than right now. And I think that's, as we're thinking about features that going into the compiler and making the language richer for larger scale development, we also need to be thinking about that tool side. It's definitely on the radar. And if you have specific ideas, I'd love to talk offline or shoot me an email, and we can set up a meeting.
My question has to do with your comments where you were talking about what you had to do to get the kind of performance you wanted out of the compiler and the way you had to really embrace a different model of programming. And one of the things that's appealed to me about TypeScript is, it's really familiar to me as a C# programmer. I can totally wrap my head around this. Do you feel a tension, or do you think that there's a direction where you might end up with a new language that promotes the kind of environment programming, or is it just getting people to code that way, or is there any sort of tension between that and the sort of C++y class interfacey?
It's interesting because JavaScript really is JavaScript is adding classes now and will in a sense embrace the dichotomy itself with sort of two different styles of doing it, and I think there's a lot of nuance in learning when one style is right versus the other, and they have pros and cons, but I would sort of encourage people to try to understand the things that really qualitatively are different about JavaScript and C#, for example, and that is the notion of nested functions and the ability to do closure over local state, and then with respect to the type system, it is the pretty profound differences between structural and nominal typing, right? TypeScript is entirely structural, and that also makes you think about things differently. I find that in well-written JavaScript code, at least, you see a lot of code where there are no classes, there is no inheritance. It's not necessary. It's one way of solving a problem. There are many ways you can solve it, and often, object-oriented programming helps you model problems in a natural way, but it isn't necessarily the right way for the for the code artifacts to come together. I mean, I often find when I write object-oriented code, it's like, here's this method that operates on one or two, or typically methods operate on more than one object, right? And so, which objects should they be on? I don't know. It's like, and it's hard often for people to figure that out, and then you end up with all these forwarder methods that forward over there, and then also in JavaScript, one of the things that I certainly learned from that exercise too is that the JavaScript VMs have a harder time optimizing heavily class-based code with lots of prototypes in it because, first of all, every function is virtual, right? I mean, everything goes through a prototype, and if you have a deep inheritance hierarchy, you have a long prototype chain, and that gets expensive also for the engines, and it's often very hard for the engines to see whether they can inline this function, and often they won't. Where if you're writing, just with a bunch of local functions that you're calling, it's almost like you're going back to programming in Pascal with functions within functions and records. Do you know what I mean? That you're passing as arguments, and it becomes very easy for the VM to see, well, hey, there are 3 calls to this function, and it's never, no one ever takes its address, no one or whatever. I can just inline it, and the VMs do, and it makes a dramatic difference in in performance.
That sort of leads to my second question, which is to you, it's Steve, right?
Yeah.
What's your anticipation? I assume that you're involved with looking at the ECMA 6 and figuring out how to implement Chakra.
Yeah.
How do you feel it's going to perform, adding all of these higher level constructs in there, and how's that going?
So so from an internal standpoint, right? I can talk a little bit forward looking, right?
This is internal.
Okay, so we're actually ahead of Google and Firefox in the completeness of our ES6 implementation. So we're pretty much done. It's all code complete. I mean, there's some things like proxies that aren't done because they're very detailed, but in large part we've got it done, and so we've gone through all that and we've optimized it. So from an engine perspective, I would say the biggest difference between the new TypeScript compiler and the old TypeScript compiler is size. So we were basically blocked on JIT throughput in the old one. So the old one was 85,000 lines, and we would not finish generating native code for it before we would finish compiling your 100-line TypeScript input, right? So, so by making the compiler more like 10,000 lines, that was by far the first order effect of making the new one faster than the old one. So the differences between using closures and using classes is less than the difference between having to JIT 80,000 lines of code versus having to JIT 10,000 lines of code. You will see in IE12 a huge dramatic difference in prototype hierarchy, class, inheritance, all that stuff. It's all getting a ton faster. So our Octane benchmark is full of objects and object inheritance, and our score is going up by almost a factor of 4 from IE11. So we aren't giving up on conventional objects. We're working as hard as we possibly can. We're doing a ton, getting a ton better, and so is V8 and the other engines. And again, the biggest effect, the biggest contributor to the 5x is the code size difference, not the style difference. So we're talking about a second order effect there. But it is true that for singleton objects, closures have a lot to recommend them. If you're going to create millions of objects, you still need to use a class unless those objects aren't going to have any methods on them. Because if you create millions of objects and they have like 10 methods each, I'm actually creating 11 objects for every object, right? Because each method is actually a free function object that could escape its scope of creation, and therefore, so you absolutely cannot do that. So never use the closure pattern if you've got a whole bunch of escaping functions. Only use it if you've got singletons, because you're going to create an object for each one of those.
Well, no, never
functions.
use it if you have 1,000,000 of them. I mean,
Right.
but if you have 1,000 of them, or
if you have
or whatever,
1,000 of them, it's fine.
yeah.
But if you have like, some big thing where you're creating millions and millions of objects, like some typical big OO program, then you either want to use classes or you want to use these pure data struct-like objects, and then have another object contain the functions that go, and that will work super well. Like Andrew says, that's probably the thing that the engines will always be able to optimize the best. But it's totally fine to use classes. It's totally, it's performing better and better all the time. Our code is way faster than 2x slower than C++ at this point. So in other words, if you wrote an object-oriented thing in
Under
TypeScript,
2x of C# or C++.
in TypeScript versus C++, you're likely to be within a factor of 2 in perf at this point. So.
Other questions? I'd also like to remind anyone that's watching online, you can email me your questions and I'll ask them for you.
Okay, so I had a small question regarding optimization also. I just wanted to understand what's the recommendation if we want to fine-tune. So we write everything in TypeScript, and then we want to fine-tune the result in JavaScript to run as fast as possible in different browsers. So what's the workflow or recommendation you have if we have all the code in TypeScript and we want it to be as fast as possible in any environment possible. We are serving to different environments to support a multitude of browsers and stuff.
Well, so what's the kind of thing that where you have the performance bottleneck? Like what kind of code is it?
So we are writing maps, and we are rendering quite a lot of stuff, and we've modeled quite a big architecture around that to basically do all that we need to do to render a map in a browser. And there are many places which are executing should be executing very fast. Some of this is pure rendering. Some of this is a lot of object creation because you're creating a lot of vector data and primitives and stuff like that.
Okay.
So we basically need to ensure that the code that is being generated out of this TypeScript is running as effectively as possible in the browser that it's currently executing in.
Well, if you send me some of your inner loops,
You just have them look at it.
the Chakra team can actually, we have a really big microscope by now because we've been building it up for like 4 or 5 years. And so we can put your code in the microscope and tell you, and it's likely that that's fairly predictive of what V8 does because we're a lot of our approaches are similar to V8, but we also have a smaller but still significant microscope for testing out V8 code.
Something else that's probably
So we can probably help you figure it out.
Because what we see right now is that in Chrome, everything works sort of fine. In IE11, sort of fine. In IE10, it's barely possible in the lower browsers. And we see some different things in Firefox and Safari browsers. Like in some places, it just chokes on performance. So I was wondering if there was any advised way to go around this.
Just send me code, SteveLUC.
Okay, I'll try to get
the way
your
to teach
contact
them
after
Fish,
this.
Steve? So you can use the profiling tools on F12.
Well, see, the issue is that depending on what the code does, we either have or haven't gotten to putting the optimization in, and so I'm not sure.
But some of it might be, like if it's a WebKit or a Firefox problem, right? I mean, then,
Well, do you know how to use the profilers that come with the browser?
Yeah, so performance is currently like one of our major problems that we have. So we're investing quite a lot into that, and there's quite a lot of people using each and every profiler they can to get some more performance out of it. So I was wondering.
I'm curious, what kind of spread are you seeing between like rendering versus compute? I mean, or can you tease that apart at all? Or
Unfortunately, I don't have that fine-grained level of information.
Yeah.
So I'm actually part of Shell and not of the map control, which needs to be the most performant. But I was wondering, so maybe I could just deliver them some information that would be helpful to them.
So the IE team, they have a microscope that will tell you that. So
they are actually working with the IE team.
Okay, good, because they can tell you exactly what's in the script engine, what's in rendering, what's in layout. And without that information, it's very hard to tell if it's even script bound.
Yeah.
People come to the Chakra team like literally every week with something where they say we're slowing them down, and a big proportion
I'm not
of those.
claiming that.
No, I know you're not. I'm just saying a big proportion of those turn out to be in rendering, and you can't tell until you like actually use the ETW events to figure out where everything is.
So I have a quick question while we're
There's
looking
one
for
behind
someone
you
else who
also.
wants
Yeah,
to ask.
yeah.
So I saw on like your slide where you had the list of companies and projects using it. I saw IE had 200,000 lines of code. What is that code?
F12 tools.
F12.
So when you hit F12 and you get all of the
It's all the F12.
debugging and profiling, all of that
Interesting.
stuff is written in TypeScript.
Okay.
The IE11 one, so like if you see, there's a new UI for all that, that's all written in TypeScript.
One of the features that was frequently requested, at least by looking at the old site Codeplex, is the ability to generate one JavaScript file from multiple source TypeScript files, and potentially also the minification at that point. Can you give an update on that?
Sure. So we do have the ability to generate one file. I mean, as long as you're not. But are you using external modules or not?
Yes, we are.
Okay. So just to recap, we can generate with the dash out compiler option. You can generate a single output file for all of your JavaScript. But if you're using external modules, the whole point of external modules is to be separately loadable. So obviously they go into a file per module. There have been requests for multi-file external modules. So the ability to designate several files, a single external module in the output. That ability we don't currently have, but it's on our radar as something that we'd like to do. I don't think it's quite as critical because if you're, for example, if you're using AMD modules, you can use this tool. If you're using require.js as your loader, you can use r.exe to package them up. And I mean, I may be speaking Greek here, but there are solutions in that space at least. But certainly, if you're just writing like plain old JavaScript without use of external modules, then you can just make one file out of it.
What about minification?
Minification is something that we've discussed on and off. We could do trivial minification very easily because we could have our emitter not emit white space and whatever, and that actually could reduce the size of your typical program by 70% or 50 to 70%, but it's not going to make it run any faster.
And you can already do that with traditional.
And you could do that
minifiers
with
now.
traditional minifiers in your tool chain. Any more minification than that starts to get into the semantics of your program. And now you have to sort of make complicated assumptions about, can we rewrite privates? Can we, do you know what I mean? Can we do this, that, and the other thing? Are we permitted to munge names of methods? We don't, because we don't know. And, you know, and so it gets complicated. And now you end up sort of with optionitis of like a whole bunch of different settings you have to understand and a whole bunch of complex logic in the compiler. And so we think about it. I wouldn't say we have a solution on the drawing board right now to that, other than to tell people to use existing minification tools for just produce JavaScript and then run that through a minifier, which we know that almost everyone does. Because the thing is, even if we did, the problem is that unless you're all in on minification, you're not going to be good enough. And to be all in is like, it's a very complicated problem, right? And now we'd have to devote a good amount of resources to that. And there are already JavaScript minifiers out there that are all in on the problem.
So I'm curious about one thing though. When you said minification, were you thinking about dead code elimination or just regular old
Well,
minification?
I meant changing all class names and function names.
Oh, okay,
to
so that's
smaller-
regular minification. Some people, when they ask that question, are asking about dead code elimination, like where they have a big library of code and they only want you to pick the stuff they actually use. But that one, the traditional one, that's
And
the answer.
do you guys use currently any minifiers? Or,
Well, for our purpose, it's not critical. But
Okay.
I think that for a wider adoption of TypeScript, it would be significant because it's already a translator from one language to another. So you have a source map. If you run it from another minifier, I'm not sure how that information
well,
would be.
typically these
carried out.
minifiers will also transform your source maps. So,
Oh, good.
Yeah,
Maybe I'm just
Uglify
familiar
will.
with the whole-
So
Yeah.
if you use something like Uglify, for example, it will do that for you. I guess what Anders and Steve were talking about is something like Google Clojure with advanced optimization. So it will inline functions, will remove dead code, will do tree shaking for you, will do the whole thing, and that is a lot of.
And that's source map preserving too, isn't it?
You would have to do the work to preserve that.
I don't know.
Okay.
I haven't used source map with Google Clojure, but Uglify will do it for you.
We have a question down there.
I actually had a somewhat related question in terms of the multiple files. So suppose I'm not using an external module, and all I want is essentially to be able to group my, starting to get complex program into multiple files. I know I can do the -- out, but in terms of the Visual Studio integration, is there any way to sort of automate that process? In the sense that what I want is to have a library that gets compiled into a single JavaScript file, so I can include it in my HTML.
Yeah.
Yeah.
And I love the save on auto, or rather the auto compile on save. But is there any way to get those together, or work around?
So one feature we know we need to do is what we internally call library projects. So the ability to take a project and split it into multiple projects, and you sort of have a dependency chain between them. And then when you compile, say, a lower level project, we compile that to a file or to many, depending on what you want, right? And then create a d.ts file that gets consumed by the next one up the chain. So you can take really large projects and split them up and have everything in a single solution with dependency tracking between all of it, which we don't currently have.
Vote on that?
Huh?
Can we vote on that?
Yeah. No, we know
away,
that
yeah.
this is what people
Yeah.
want. Yeah, absolutely.
It's definitely on the radar.
It's on our radar. Yeah. It's just.
I guess. Is there something you could do? I mean, short of just creating a little, a bash script that you just remember to double click on before you hit F5, would that actually be the most elegant
you can
solution?
do that. You can do that today. I mean, you can set it up today. It's just that we don't have the Visual Studio integration of a project that's structured that way. Or maybe am I answering
No,
the right
it's just
question?
in terms of setting up the simplest possible workaround today. What would be the guidance? Would you add a build task? Would you just?
So the question is it a project to project reference? So you have multiple projects?
No,
Or is it
just
a single project.
just you have some TypeScript that you say you have in a folder. You want to restructure it so that it's multiple files, so it's easier to navigate.
So you can do that today, actually. If you create either on the latest Visual Studio 2013 update 3, if you create a JS project, or you can create a C# project and include there's a template. Even if you just create a new project, there's a template, and then you add your files. And in project properties, you can specify that you want it to output to a single JavaScript file, and it will do that for you. You get the source maps, you get the declarations, you get the whole thing. The problem is extending that to multiple projects. So you want to create your library and give it to somebody else to use it, and then when you edit your library,
Is that a project that's different than like web projects?
No, that's
I guess
the-
for now I've always just created a
That's the
new web
C#
project.
web project. Yes, that's the one. We also have support for JS Proj, and if you want to support any other projects, it's just like including our targets. So we can, if you need help with that, just let me know, and we can.
If you want to do a completely custom build, we have a lot of custom builds in ours. So we use Grunt, so you're welcome to contact me, and we could tell you how we do really sophisticated builds, right? But it completely breaks out of Visual Studio at that point.
Everyone rules their own.
So I had another question. It's actually something I've been meaning to email you about, that we ran into a situation. We do a lot of Node.js development plus client development. And so we're always trying to figure out how can we share code across those things. And so currently, the state of the art for us for sharing code is just d.ts files, right? And we share our interfaces across, which has been tremendous to help keep That's another reason why we've switched to the data and interfaces to type everything. We did run into one situation. We wanted to share enums across the client and the server. So we defined those in the d.ts file. And of course, at runtime, it said, oh, there is no enum that's been defined, right? And so we have yet to figure out how we could get it to basically also at compile time generate the enum implementation.
Yeah.
Didn't we have a flag at one point?
Not too well,
to
but
generate
To
them.
spit the enum?
But
For
Steve wants to
inlining,
sort of
we
go the other way. It's like you
Right. And I had to scratch my head. And I'm like, oh, of course. Because a d.ts file is basically just says these things should already be there.
Right.
Right.
Yeah.
And so an enum is a programmatic thing, a thing that has to be generated at compile time,
And if
which is
you-
why.
and if you
he
use
wants
it-
to take a d.ts file and generate an implementation from the d.ts.
Yes, exactly.
I
And the problem is we
actually-
tried to define one client side, and then it conflicts because it's been defined twice. Right, because it sees the d.ts file version.
But you've got
So
an
we've
enum.
removed them from, and we just define it twice, is what we
Right.
do now,
Okay.
which is kind of
But
brittle.
enum has, when it's a DTS file, it should be fully expanded, so it has the numbers, and then those can be inlined.
But
So
the value is not created in the JavaScript. So you say
Only-
the
only if
DTS
they're
says
not
that the
computed.
enum the
yeah,
JavaScript
but
doesn't find it.
okay, yeah. If you're just
Yes.
doing the literals, like numeric literals, those would
Right.
be inlined. But on the
It's the same as if you say a class in a DTS.
Yes, it's the same thing. You would have to pre-implement the class. And class I totally get, but the enum threw me off at first when we first tried
Enum's
to
a
do
lot
this.
like class.
Yes, exactly. Yeah. But we want to use enums in our stuff. So we've had to revert back to using strings as the way that we...
So what you would have is like a bunch of interfaces, and you can implement an interface with a class, but you cannot implement an enum.
Exactly.
You have it declared, you cannot redeclare it because that would be a conflict.
That's the thing.
Anyway, just take it as an issue.
No, that's an interesting idea.
You can run the compiler and say like, please generate me a D file out of my source, and then shares this one.
Right.
Yep.
And then share them both, the JS and the PTO.
I have a question around debugging with source maps. So I'm using this functionality where you can debug in Visual Studio directly TypeScript without, it's difficult when you're writing code. You need to open a browser, separate debugger, find the matching line, set the breakpoint, and then this feature is very handy to me. Now I'm having problems with it. I'm still using Visual Studio 2012, and previously, like a couple of months ago, it used to crash a lot when you're doing this. Like it consumes all memory. Then I need to shut down Visual Studio, start again. But it was still useful. I was using it. Then a couple months back, we switched to AMD, and then this feature didn't work out of the box anymore. I'm not sure why. So I added some build task that will copy the JavaScript maps file to the right place, and then it started working. But then it started crashing Visual Studio to the point that it is not useful anymore.
But you're on the 2012 version?
Yeah, so I'm wondering if I switch to the newer version of Visual Studio, would that help, or is this a known issue?
We fixed quite... Go ahead.
Yeah, so we fixed a lot of bugs with debugging, but just send me an email. Anybody here can just...
So what happens typically is sometimes when you got to the end of the function and there's a breakpoint, and then when it exits out of the function, it goes into some wormhole. The Visual Studio just freezes, and you need to kill it.
We need to look at these. So if you have like a sample where it is crashing consistently, just let us know, and then we'll look into it. And once we have a fix, we'll share it with you, so we can unblock it.
Okay, and one other small question about incremental compilation. Is there any plan to make it more in-depth? Because currently, only if you link a couple of projects,
So TypeScript doesn't support a C++ style incremental compilation where you have an object file for every source file that if you didn't touch the source file, the object file will not be created kind of thing. We support more of like a C# kind of thing, which is like the unit of compilation is, you will either do it as a whole or you will not. And if none of the sources have changed compared to the outputs, we will not touch that unit. And this is something that we already support in the last update 3.
Yeah, so we have that in a code. I'm just wondering if your project is built out of modules, would it be possible somehow to rebuild only modules that change and ones that depend on them? Would that be any gain?
Well, what kind of modules? Are they all AMD modules, or are they?
Yeah, they're all AMD modules.
Yeah, with AMD modules, it might be possible. With internal modules, we have rules for how they merge that actually make it very hard to do it correctly in all cases. It's not something that is, I think the thing that we're gonna probably focus on the most is getting library projects to work, and then you can structure your big solution into multiple.
Yeah, we have some simulation of that, basically. We put the DTS that it depends as a TypeScript compile, and then we put those are defined as inputs, and then if that changes, this will compile. If it doesn't, this doesn't
that's what
compile.
we would do is like basically, make
so
sure.
So I'm guessing that with the new compiler is 5 times faster, and we don't really need this one, right?
And for external modules, I would highly suggest using something like compile and save, because that will give you exactly what you want. Like every time you will update one file, it will only compile that file.
Yeah.
Okay.
Yeah.
Alrighty, so I think we're actually at the end of this first session. I'm sure these guys will still be around if you have some more questions. So we're going to take like a 30-minute break. We'll come back at like 3:45, and then there's a number of teams that want to present some stuff that they're doing. We have actually Eric Gamma, who is currently in Switzerland, is going to talk about a bunch of stuff on Monaco that should be a good talk over Link. There is food and drink directly behind us, or there should be. So I
gonna
was
be-
told.
gonna be
So
late for, Eric
anyway,
there.
so let's break for 30 minutes and then we'll come back. 3:45.
Boy, yeah.